How to Use a 3D Printer, written by HowExpert Press and Zachary Heston, narrated by Zachary Heston. Copyright and published by Hot Methods, Inc. How to Use a 3D Printer, written by Zach Heston, narrated by Zach Heston. Copyright by HowExpert.com. So you've heard of 3D printers and you want to find out more about them. Well, here's the place to be. I will show you in a 7-step guide what 3D printers are all about, how to use one, and even help you decide which one is right for you. Chapter 1. Getting Started. What is a 3D printer? Well, a 3D printer in simplest complex is a printer that makes three-dimensional objects usually out of plastic. Since we are talking about more consumer-based 3D printers, I will stick with the basic type of printer, Fusion Deposition Modeling, FDM, or Fused Filament Fabrication, FFF. What these more complex names mean is basically a machine that will lay down layer after layer of plastic, fusing each layer to the next, ultimately forming the object. To get the picture in your head, think of a hot glue gun, how it pushes out that thick, goopy glue. Imagine running the hot glue gun in a square, then placing more glue on top of the old glue, and keep doing that until you have a nice little cube. That is basically what a 3D printer does, at a much more fine level, usually 1/10 to 3/10 of a millimeter, sometimes less for superfine detail. This entire process is automatic, however. Can I use a 3D printer? This is a true question many ask. Before jumping into the world of 3D printing, think. Do you have patience? 3D printing can be a very long process. Do you have basic skills of tinkering? The more affordable a printer is, the more likely it will malfunction or have flaws. You must be willing to tinker and try to improve on your printer. Do you have money? 3D printers can be very expensive, from the printer itself to the filament plastic it uses. Finally, one of the most important parts is, what will you use it for? Many people forget to ask themselves this question. A 3D printer is an amazing tool that can be used in many different applications. If you plan on buying it for just printing toys, it may get old after a while. Many use 3D printers for making replicas of things, props, robotics, or any other hobby. Some people even find success in selling their 3D prints. However, this goes into an entirely different subject that will be covered later in this guide. Even if you don't have a hobby application for it yet, then maybe it is time for you to get into a hobby that 3D printing can apply to. Buying a 3D printer. So you've decided to buy a 3D printer, or at least you're thinking about buying one. I'm not going to lie and say this step is easy. It's not. Finding the right printer for your situation within the right budget is difficult. You will have to do your homework and look into different printers' prices, reviews, specs, and more. Price ranges. 3D printers come in different price ranges, just like anything else. I will break them down into 5 different price ranges to make it easier for those that have a very specific budget, and then recommend a printer out of the category to check out. The first range would be the entry-level printers. Printers in this price range will be below $500. This is why they are known as entry-level, as it's better to try a cheaper alternative than go full-blown into something more expensive. A lot of these printers, however, will come as kits rather than a fully assembled version. For the fully assembled version of a lot of kits will put you outside the entry-level range. Building a 3D printer can be good for you though, as you learn exactly how it ticks, and will in the future know what to or not to look for when purchasing a better, more sophisticated printer. Printers in this price range are also made with cheaper parts or designs. Be wary of that and look for printers with good reviews, as you don't want to get a printer that barely works and will have to put even more money in it just to get it to print. For the printer I recommend to check out, everyone in fact, it's just more than just a budget printer, is the Wanhao i3 V2. This printer has an amazing build with strong metal components, a decent 8" by 8" by 7" build platform, and overall quality parts. The Wanhao, after fine-tuning, has been known to outperform printers 2 to 3 times its price range, and is also backed by a huge community of people that own one as well. Coming in at $400, this printer is worth checking out. The next price range is dubbed the affordable range. Ranging from $500 to $750, these printers are usually better built than entry-level printers, but are still in the affordable range for your average consumer. However, this is a very strange price range. The printers are very similar to the entry-level printers,
But if you pay an extra $250 to $500, this will put you in the next range and give you significantly better than entry-level or affordable. The one perhaps advantage over entry-level printers is you can find printers in this price range with enclosures, which can help keep noise down and print filament that is sensitive to cooling, such as ABS, what Legos are made out of. For this price range is tough, but one of the most highly rated printers in this range is the FlashForge Finder at $500. Yes, it sits right at the edge of going in an entry level, and you probably could find one used for less, but even so, it better suits this range with an enclosure, which may be the only thing it has on the Wanhao. The third range is known as the mid-range printers. Ranging from $750 to $1,000, these printers are an amazing example of constantly changing technology, and some consider these printers on the lower end of high-end printers, as they perform amazingly without costing you an arm and a leg. Printers in this price range truly differ from the previous ranges, as they have many different options, better builds, bigger build envelopes, and higher quality printing. This is also the start of good plug-and-play machines. They don't require a lot of maintenance, are extremely easy to use, and work out of the box. I would only recommend these printers though for people who either have previous experience in 3D printing or know they are going to need this no matter what, as this would be an expensive letdown if you end up not liking 3D printing. For the price range printer, I would put out the Qidi Tech 1, a metal frame with a decent 8.8 inch, 5.9 inch, 5.9 inch build area. Coming in at about $700, it is at the lower price range of this tier. A further note, though, on printers in these ranges, with these plug-and-play designs, you lose customization that earlier ranges were full of. Some printers in these ranges here will still be customizable, but for many, this is not the case. The next range is dubbed the enthusiast level. Costs ranging from $1,000 to $2,000, these printers are for none other than enthusiasts. These printers are some of the best printers on the market without paying $2,000. Zortrax M200 is the winner of this price range with some of the best reviews. Coming in at $1,935, this printer is truly a plug-and-play machine. Little or no work is needed to be done, except pulling it out of the box, to get it to print quality objects. Now, I'm not putting down the M200 saying it is a bad machine or anything. However, this is an example of paying more for plug-and-play. Yes, this machine is made with much more quality parts. As if you cannot tell by now, I like referencing the Wanhao i3. Its build platform is only 5mm taller with the exact same X and Y dimensions. Printers in this price range are a lot of times what set people apart from tinkerers or just users. You don't or you can't tinker with most printers in this price range with how they are built. If something breaks as well, replacement parts can be outrageous, as most parts are made specifically for each printer and are not something generic. An example of this is the MakerBot 5th generation smart extruder. The extruder itself is quite smart in some cases, having the capability to detect jams if you run out of filament and more. If this extruder were to break after its 6-month warranty, it will set you back $200. Be wary of things like this. You don't want to have to be saved for months and months, for example, buy it and have to pay even more money. Read reviews and information in this price range as well. Now finally we come to the last price range. These printers are known as premium level printers. These printers are the ones that exceed $2,000. When you buy one of these, you are buying something that usually features stuff that none other printer has, from huge build areas, special dual extruders, and more overall ease of use. Another relevant printer in this price range is the SLA printer, which uses lasers and a resin to cure an object with extreme detail. However, I will not go any farther into this form of 3D printing, as the upkeep and cleanup is outrageous in price and mess. These really are not consumer printers, so to say, and are better for companies for fine detail prototyping or jewelry. The printers I've selected from this price range is based off of what I have seen and heard about it, and is none other than the Raise 3D N2. This printer comes with a full enclosure, an LED touchscreen, a massive 12-inch by 12-inch by 12-inch build area, dual extruder options, as well as more. This printer also has the capability to print resolutions of 0.01 millimeters compared to the fine detail most printers print at, which is 0.1 millimeters. This printer also has the incredible features such as one of my favorite, print saving on power loss. If you lose power to a printer for most every printer, you lose the print, as the only way to continue is either to restart the entire print or measure and print the remaining parts of the print separately. With the Raise 3D N2, this will not happen. Now think long and hard about your choice. Your choice will ultimately reflect your experience with 3D printers. If you buy a bad 3D printer, you are in for a rough road ahead of fixing. If you buy a tinkerer's printer, be prepared to tinker with it for obvious reasons to improve on the original design to make it better. And if you cough up the money for a high-end printer, you will likely find it extremely easy, unless this quality printer turns out to be not so quality. Read reviews as you did to this guide. Join groups dedicated to 3D printing and ask questions. All I can say now is good luck finding your printer. Unboxing. Now we get to the box, the only thing that is holding you back from your 3D printer. Now this part is very essential and I advise for you to read carefully. The first thing you want to do before unboxing is check the box itself for damage. 3D printers typically do not like to be jarred, hit, etc., as this can damage all sorts of different pieces. Take pictures of any areas of concern, such as dents, rips, or even if the box looks open and resealed. This is proof you can use later on if your printer is missing pieces or damaged in any sort of way to get free replacement/parts. Now before you open the box, look for warnings that will tell you not to open the box with a knife or something sharp. Sometimes the printer components could be right underneath the top, so you don't want to accidentally cut something. Once you have it open, take out any paperwork that is usually at the top. Read through it and see if it has any unboxing instructions. If not, continue to pull your printer out carefully in a nice open area. If something doesn't want to come out, check to make sure it doesn't have another piece attached to it. Now take any styrofoam out of the way once the printer has been placed. Mission accomplished. It is out of the box, but now there's more to do. Some printers come in few different pieces for easier shipping. Follow directions and assemble it. Now if you bought an unassembled kit, now you must assemble the entire thing. Good luck. Some printers might also include shipping bolts to prevent certain pieces from sliding, or tape over end stops to prevent damage. Most printers are extremely well packed and have loads of things protecting them, so you should look out for things like that. Now, of course, you should have been following the directions supplied by the manufacturer of your printer. Reread it again and keep looking out for things needed to be done during unboxing/setup. If you miss something, your printer may not work or it even could damage itself when turned on. If you believe you have done so, it is time to move on to the next step. Calibrating/first print. Trust me, nothing is more thrilling than your first test print. The joy of seeing your printer do its job is amazing. However, you can't just do a test print once it's assembled. There is work to do. You should be following your directions as I've told you for the upteenth time, but I will go over the most basically say. If you have a 3D printer, like most out there, you must go through the hated process of leveling. Leveling your bed is the process of making your printing bed parallel to the nozzle. If you do not do this, this can result in poor bed adhesion and ultimately a failed print. As long as you print at reasonable sizes, 0.1 to 0.3 millimeter, you will need not the most perfect leveling, as the printer will, in a way, compensate for this, as in areas where it is too close, it will end up not being able to extrude a lot of plastic, while in areas where it is too low, it will extrude as much as possible, ultimately leveling out a perfect leveled print. If this ends up being made into a video series, I'll be able to explain better, so make sure to check out if there is one. Some printers will not need to have their beds leveled, but if you do and your printer manufacturer doesn't tell you how to, I recommend using a piece of regular printer paper and starting in the front left corner, moving to the far back right, then the back left, then the front right, making sure there is a tiny bit of resistance as the paper slides under the nozzle. Before you do this, make sure your nozzle was homed in on the Z-axis as it may have lifted slightly. If you happen to be having issues leveling your bed, check your Z-axis rods. Sometimes one side has a little lifted or lower side, causing your bed leveling issue. The easiest way to do this is to home all your axes. Then measure the Z-axis rod distance from the bottom to where the gantry starts on the side with the end stop. Now you may ask why. Well, the side with the end stop is always right, as it will set itself to the same height every time when it hits the end stop. The other Z-axis rod, however, only knows to stop when the end stop on the other side is pressed. So if it had not made it all the way down, it will just stop regardless. So now with their measurement from the one Z-axis rod in mind, measure the other side. Then manually twist the coupler, what twists the stepper motor, to the Z-axis rod, until the same measurement as the other side. Now your axis is level. You may have to check this every once in a while, as one of your z-axis stepper motors may be ever so slightly slow, causing it to get out of alignment after so many uses. Now it is time for your first print. Now many printers will come with the test file. This is the best option for your first print. Load it up and load your filament as per the directions and start it. Now sit back and enjoy watching your first print come to life. If you start to see plastic peeling from the bed, you should probably stop the print, as this should not be happening. Check your bed leveling and the temperatures, then try again. However, long later, when your print is finished, carefully take it off the bed, as you don't want to ruin your first print. It turned out good, hopefully, didn't it? If it didn't happen, it is time to check your troubleshooting guide. After this print, usually a small one, it's time to start printing things that you choose. And we'll get to that later on in the guide. Now, more work will be required, sadly, as test printers are usually made by the printer gods themselves. They are perfectly tweaked G-code that always works, but you have to go straight into printing something else, you will have issues. Follow the rest of this guide to understand how to prepare your printer so you don't get prints with issues. Where can I get models from? Well, there are many places you can download .stl files, the file used for 3D printer. One of the most best-known websites is Thingiverse, a website owned by MakerBot. Users from all over the world can upload their models to the website and share them. You can also find the most simplistic things on Thingiverse, such as a hinge, to the most complex things, like a model of a T-Rex skeleton. Some people even allow customization of their files through Thingiverse customization app to be able to change sizings, lettering, etc. Another good website is UMagging, owned by Ultimaker. Their website is similar to Thingiverse with a lot of variation in designs and things to print. Now you may be asking, are there any other websites? Well, yes, there are plenty more. I only choose 2 for 3 reasons. The websites are reliable and you are not at risk of downloading viruses. Most of the models are 3D printable and all models are free. The 3D printable part I will get to later and the free part I will hit now. Many professional designers will make amazing designs, like a replica of a Millennium Falcon that opens up to the inside. And then they turn around and sell the files for tons of money. Thingiverse and UMagging don't allow people to sell the models through their website, so anything on there will always be free. So just search up what you need and pick the best designs that fit your needs or wants. Worst scenario is you can't find exactly what you're looking for. This is when you find a 3D modeler to make it for you. If it's something extremely small and easy, you may be able to find someone in a 3D printer group to make one for free. But if your idea is a full-scale power armor suit from Fallout 4, you're going to need a professional designer and a few $100 to $1,000 to pay them. Okay, you probably won't be designing a full-scale suit, as those are expensive just to print, let alone design. If your idea is, say, a model of a Super Bowl trophy, it'll probably cost close to $20. What does ripping from a game mean? Well, in simple terms, 3D games use 3D models to be the game. People will rip these 3D models from the game and turn them into a .stl file. This may sound really cool, but at the same time, it's risky. 3D printers have limitations on what they can print. Too much detail or too complicated structures or overhangs will cause the prints to fail, even with the most fine-tuned settings. When people design models from scratch, they take into account that a 3D printer must be able to print this and optimize the file to be printed in such ways as cutting it into smaller pieces, removing unnecessary details, etc. If you notice the ripped 3D model of a Honda motorcycle, you will see complicated details such as a spokes, engine, and more. This design is likely overcomplicated for your typical 3D printer and will not turn out anywhere close to what you want it to look like. No, I'm not saying anything like this is not printable. You can try, but don't say I didn't warn you. The kind of print would be more suitable for a more detailed printer, such as an SLA printer, but even then it may be iffy. Commercial use. So now you're ready to start selling your printer objects to earn some money. Now some people are good at this and find something that sells good, but there's a problem. You will likely be downloading these models off a free site such as Thingiverse. You must pay extreme close attention to tags such as if it's allowed to be used for commercial use, sell it. In some cases you can just sell it, others you must give credit, and others you cannot. Even if you bought the design from a website, you must make sure it's allowed to sell them. A great way to avoid all these problems, though, are just to design your own models, as then you own all the rights to them, or have someone else design them for you. Now, if neither of these sound appeasing, the final way to avoid legal problems is just to open up a 3D shop that prints whatever is given. For example, 3D Hubs does a hub where users upload a .stl file to the website, and by formulas you set, it tells them how much it will cost them. This way you are technically selling the file, even if it can't be used for commercial use. Now, this isn't the most solid way to go about doing it. Some people would dispute this way, but you are unlikely to run into any problems. Chapter 5. Filament. Okay, most companies give you a 10-meter test spool of filament. This is usually just enough to print the test print, and if you're following the 3D model downloading portion, you probably are about to start printing something more. This is where you must buy your own filament. Now I'll be explaining my opinion. My filament may work for you, but it may not, so I advise you to read into more reviews of different brands. Filament types. The most basic filament around the world would probably be PLA. This is most likely what your sample filament was. The filament usually prints around 200 Celsius to 215 Celsius. It has good layer adhesion and isn't affected too much by cooling, however it still needs it. It also can be printed without a heated bed. This is also one of the cheaper filament types. A downside though is its lower temperature causes it to warp in a hot summer day. Another common filament is ABS. This is the same plastic that Lego bricks are made out of, so it is a very strong plastic. It prints about 20 degrees Celsius above PLA. The downsides, though, are it requires a heated bed and is very susceptible to warping, as without an enclosure, breezes can make your part cool unevenly, causing the layers to warp and not bond correctly. The filament is generally not good for beginners, as it can be a true challenge, but if you successfully print it, you have an incredibly strong part. The third filament I would recommend is PETG. And yes, I know, these are hard names. Nobody actually uses the full name anyways. The filament is like a perfect combination, I would say. It is quite easy to print like PLA, as it has amazing layer adhesion. It prints about the same temperature as ABS and doesn't require a heated bed or an enclosure to keep the cooling perfect. This filament is also incredibly strong and has a bit of flex as well. The filament is overall an amazing choice for any project. Now, there are other types of filament, such as Ninja Flex, a rubbery, very flexible filament, TPU, nylon, and more. But a lot of these filaments are either much more advanced, unneeded, or I have not have enough reliable information to recommend them. Filament brands and prices. So now I have listed 3 different types of filament, but now is where to buy said filament from. I am more of a budget person, so I do not like spending $50 for a half a kilogram roll of plastic. There are many brands out there, but these are 3 ones I have either heard the best reviews about or have used with great results. Now we go to inland filament. This filament, a product of a computer store, Micro Center, is widely thought to be rebranded eSIM filament. No matter what it is, I have found that its PLA and PETG turn out amazing, as long as you tune your printer settings correctly. I cannot help you there, as spools vary and so do printers. The filament can be ordered from microcenter.com and shipped or picked up directly. If you live close to a Micro Center, I would advise you to buy a filament online and then have it pick up at store. This is because the filament in the store is actually a few dollars more expensive than online, so you could save money. The PLA filament costs around $15 a kilogram, while the PETG costs around $18. I cannot say more about the ABS as I've never used it. All in all, this is one of the best cheap filaments. The next brand is known as Hatchbox. I have used their PLA and it's great, amazingly smooth objects. The spools even come in a nice cardboard box that can be used to store your tools and more. This filament can be found on Amazon and a few other retailers, but the problem is the filament is extremely popular. The PLA can usually be found on Amazon from $20 to $25 depending on the colors. The weird colors that nobody buys will always be less than the basics such as white. Overall, I have found that Hatchbox also has a better filament diameter compared to Inland, which is the reason for smoother finishes. Now I cannot speak for the PETG, which runs close to $34 on Amazon, as the price has always steered me clear of it. The final brand is Maker Geeks. I have yet to use their filament, but I have heard many good reviews about it. They sell filament such as clear to even special PLA that is much stronger than the original or even ABS. Their filament costs around $18.50 a kilogram, with some of their specialty ranging higher. A good trick to do this is if you need it in bulk for low cost and don't care about the color is to buy their grab bag. For $36 you will get 2 random colors rolls for whatever type of filament you choose, with the exception of Raptor PLA, which will add $15. And occasionally they will even go for $60 for 4 rolls, which saves you $12. Now, your choice of filament is entirely up to you. Ask around people in printer groups what they like or use. Just remember though, just like with 3D printers, the most expensive option is not always the best choice. Chapter 6: Software. Okay, now you have a printer, models, and plastic. What is next? Well, you just can't throw a 3D model into a 3D printer, as it does not understand that format. It must be converted into a file known as G-code for it to print. In these following steps, I will show you what to do. Slicer software. A program that converts a 3D model into G-code file is known as a slicer program. What it does is slices the 3D models into layers, with each layer containing information telling the printer simple commands such as move here, extrude this much, heat to this temperature. So in reality, G-code is not a form of 3D model, it's just a huge list of commands that form a 3D model. Now, some printers must use special G-code for their printers only, so sometimes you are stuck using one type of slicer software. However, most printers are open, allowing you to switch freely. Many slicer softwares offer different things. Some even cost money, but when it comes down to it, they all do the basic function of converting STL files to G-code. Now in slicer software, you'll have many options to change settings, which is where fine-tuning comes in. Temperature, infill, shells, speed, and all more are things needed to be adjusted before you can export your G-code to your 3D printer. If you need help troubleshooting something, Simplify 3D offers an amazing guide and offers things to change to fix the problems. What slicer should I use? Well, if your 3D printer requires a stock slicer, sorry, but you're stuck with it, unless you are good with coding and other lots of goodies. If your printer doesn't need a special slicer, I have 3 different slicer softwares for you to choose from. The first one is known as Cura. Cura is run by the makers of Ultimaker 3D printers. Their software offers many different settings with a simplistic layout. If you only want to see basic settings, you can choose that, or go deeper into and change little tiny things. Many printer companies even offer special profile settings for their printer. This program is also free and can be downloaded from ultimaker.com. The second program is known as Slicer. Pretty easy to figure out. It's a slicer program, right? Slicer is an independently run slicer. It offers many advanced options such as cutting objects into smaller pieces and many more. The only downside I can think of is it looks older than and not as smooth as many of the newer slicer softwares around today. But do not let that fool you. It is an incredible, capable, and good slicer. The final slicer I have on the list is called Simplify 3D, and by no means is this program simple. Simplify 3D, I would say, has the most options and settings than any other slicer today. With its ability to add customized supports, switch profiles and settings mid-print, and more, it is by far puts itself near the top of all slicers. There isn't a catch to this amazing slicer, though, one that will set you back $150. Yes, this one of the few slicers that are not free. This slicer is by no means for beginners, as you would never need such a program when learning. Now, for more professional users or people that need extreme details and fine-tuning, this would fit you quite well. Now, choosing a slicer isn't really that hard. Most do the exact thing. You have to try them out and see which works better for your needs. Most slicers don't care what printer you are using, and printers usually don't care what slicer you're using. As long as they both use the same G-code, they can't tell the difference. How to use the slicer. By now you must have at least chosen a slicer to check out. Using a slicer is fairly simple. For beginners, you will want to stick in the basic section. I cannot go too deep into how to use a slicer as they vary from each, but basically you will import your model. Then you will change the settings for the model such as infills, the number of perimeters, etc. Next, you will export the G-code to an SD card and insert straight into your printer or just print from your computer. Now, I would recommend using an SD card if possible, as if your computer performs an update, crashes, or the wire becomes unplugged, you will lose all your progress on your 3D printer and have to restart. If your printer for some reason doesn't have an SD card slot, you can always use something like Octoprint, which is a Raspberry Pi that will plug into your USB slot and act as a mini computer. You will send the G-code wirelessly and not have to worry about your PC shutting off, as the G-code is saved on the Pi. Octoprint also gives you the options to view your print while away if you have a camera and even remotely stop your printer. As I've said before, printers vary, so read up on your printer on how it accepts G-code files. Chapter 7: Modding. Now look at it this way. We all strive for perfection. Many prints can get some really amazing prints right away, but of course those printers cost lots of money. If you want to get better prints, you'll probably have to tinker with your printer to get them. When should I mod? Well, that is entirely up to you. If you see a problem begin to form or see others with the same printers who are getting better results, it's probably about time. Some people, though, choose to mod right off the bat, even if there are no immediate problems present. This future-proofs them. It also depends on what you are printing. Personally, I print items that need fine detail and to be smooth, so I don't have to do a lot of post-printing work. Now, if you're just going to do a lot of prototyping, then you may not care about lines showing. Sometimes printers are just made with design flaws. For example, my Wanhao printer, the top beam sits too low for it to get all 180 millimeters of Z height, so I modded it to lift it up more. Modding also depends on what kind of printer you have. Most Prusa-style printers are very moddable, as their core printer they are based off uses printed parts to function. Now, the more expensive printers that are built-in enclosures, such as MakerBot, Ultimaker, and more, are harder to mod, as their design really doesn't allow for it. Prusa-style printers most of the time can be completely disassembled and reassembled to allow for modding, which, as more expensive ones, is much harder to take apart. This doesn't mean you cannot mod more expensive printers, it's just usually harder and sometimes not ever even needed. What should I mod? Once again, that is entirely up to you. What you mod is based off what you can feasibly mod on your printer and why you should. As the old saying goes, if it's not broke, don't fix it. Now, it doesn't have to be actually broke. For example, changing a nozzle to be a better version is kind of like fixing a broke nozzle. Some examples of modding would be Z-bracing. Prusa-style printers can be unstable near the top, causing Z-banding. This is where the layers form deep grooves every so often. A simple solution is to have the Z-brace rods attached to the top of the printer down to the bottom of the printer. This makes the printer extremely rigid and prevents wobble. Another example would be fixing bent or crooked Z-rods. Sometimes in transit, the Z-rods, what make the printer rise, can get bent. Or when assembled, the rods are nearly impossible to make straight, unless it is secured from both sides. If the rod is not attached to the printer at the top, it can wiggle, once again causing Z-banding. To fix this, you can install flex couplers instead of solid couplers. A coupler is a usually small piece of plastic that attaches to the rod of the stepper motor. Flex couplers can bend to compensate for this wiggle and force it to stop. Another thing people mod is their nozzle. Sometimes printer companies use really crappy nozzle or bad nozzle setups. With some extra work, you can switch out the nozzle type or change from a direct drive setup to a Bowden setup, or vice versa. A direct drive extruder uses a stepper motor right on top of the nozzle heater. This pulls filament to it and pushes it directly into the heater. A Bowden setup, most commonly used on Delta-style printers, will pull from it usually from the bottom from the printer or near the top and pushes it through a tube that leads to the heater block. Both setups have their ups and downs. What you mod is entirely up to you, as I've said before. Usually you can find a community dedicated to your printer or a similar printer, and they can assist you in how to mod it or what to mod. When modding though, pay close attention to the amount of money you spend. If you buy a $100 printer, but put $500 in mods, why don't you just buy a $600 printer that wouldn't need mods? Unless, of course, there's some other reason for doing this. This was How to Use a 3D Printer, written by Zach Heston, narrated by Zach Heston. Copyright by HowExpert.com.
How to Use a 3D Printer, written by HowExpert Press and Zachary Heston, narrated by Zachary Heston. Copyright and published by Hot Methods, Inc.